In late 2025, fresh ice grains from Saturn's moon Enceladus were found to carry organic chemistry from a hidden ocean, not life, but chemistry life can use. For most of human history, we believed all life traced back to one source, the sun. Sunlight was the first link in every chain, the origin of every meal. Then we went deeper, down to the floor of our own ocean where sunlight has never reached. And in that absolute dark, we found entire ecosystems thriving, fed not by light, but by chemical energy rising from the rock itself. That discovery quietly rewrote the rules, because if life does not always need sunlight, if some ecosystems can run on liquid water, chemical energy, and the right chemistry, then Earth is no longer the only address worth searching. It's just the first one we could reach. So look outward, past Mars, out to the giant planets, and you begin to find them. Worlds sealed inside ice. The first is Europa, a moon of Jupiter, nearly the size of our own moon. Its surface is a shell of frozen water, cracked, scarred, and stained with rust-colored streaks. A surface that looks broken on purpose, as if something beneath it never stops moving. The strongest clue is one you can't see. As Europa orbits, it distorts Jupiter's enormous magnetic field, and the simplest way to explain that is a layer of salty, electrically conductive liquid beneath the ice. A global ocean, likely kept liquid over geologic time, not by sunlight, but by Jupiter itself, whose gravity flexes the moon from the inside and helps prevent the ocean from freezing solid. Beneath a shell of ice, perhaps 15 to 30 kilometers thick, we still don't know exactly, that ocean may hold more than twice the water of every ocean on Earth combined. One small moon, more sea than our entire planet. And we have never seen a drop of it. Then there is Enceladus, a moon of Saturn so small it would fit inside a single country. From a distance, it looks like nothing more than a bright white pearl. But at its south pole, something extraordinary is underway. Through long fractures in the ice, scars scientists named the tiger stripes, Enceladus is venting itself into space. Jets of frozen ocean erupting hundreds of miles above the surface, drifting out to feed one of Saturn's rings. Which means, for this one world, we don't have to drill through the ice to reach the ocean. Enceladus is sending it to us. And we caught it. For more than a decade, NASA's Cassini spacecraft circled Saturn, and on its boldest passes, it flew directly through those plumes, sampling the spray as it erupted. Cassini's mission ended in 2017, but its data did not. In late 2025, scientists looked again at ice grains collected about 13 miles, 21 kilometers, above the surface, in material only minutes removed from the ocean below. And inside those grains, they found organic molecules, carbon-based compounds, several never identified there before. The kind that, on Earth, take part in the chemistry that leads toward life. Not life, but its raw ingredients, carried straight up from a sea no one has ever seen. An ocean, then, with water and with organic chemistry. Another major requirement would be usable energy, and Enceladus appears to have that too. Years earlier, in that same plume, Cassini had detected molecular hydrogen, a gas best explained by hot rock reacting with seawater on the ocean floor. A signature consistent with hydrothermal reactions, the kind of process that powers dark ecosystems on Earth's seafloor. Water, energy, the chemistry of life. At Enceladus, the case becomes unusually complete. Liquid water, usable energy, and organic chemistry appear to overlap beyond Earth. And that is exactly where this story demands discipline. Water is not life, organics are not life, energy is not life. Having every ingredient is not the same as finding the meal. A world can be habitable without being inhabited, and science is arguing with itself, as it should. The freshest grains suggest that chemistry is welling up from the ocean, but in 2025, a laboratory study pushed back. Bombard Enceladus-like ice with radiation, and you can brew similar molecules right at the surface. No ocean required. So the question stays open. How much of this comes from the sea, and how much from the ice above it? That uncertainty isn't a crack in the story. It's the reason we have to go back and look closer. And we are going back. In October 2024, NASA launched Europa Clipper, the largest spacecraft it has ever built for a planetary mission. Its solar wings spanning wider than a basketball court. It carries no instrument to detect life. It was built to answer a narrower, sharper question. Could Europa support it? Right now, it's in transit, slingshotting past Mars, then back past Earth at the close of 2026, borrowing the gravity of each to reach Jupiter. It enters orbit in 2030, and from the following year begins dozens of close passes over Europa, reading the ice, the ocean beneath it, and the chemistry locked inside. It will not tell us whether anything lives there. It will tell us whether anything could. And Europa and Enceladus are not alone. Ganymede, Callisto, Titan. Across the outer solar system, one icy world after another hints at water hidden in the dark. Oceans may be among the most common places in the universe for liquid water to gather. For most of our history, the search for life beyond Earth was a search for another Earth, another blue planet, warmed by another sun. The deep ocean taught us we were looking for the wrong thing. Life may not need sunlight in the way we once assumed. It may need water, energy, chemistry, and time, even in the dark. We have not found life under the alien ice, not yet. But for the first time, we know where to look, and we are finally on our way.